Assalamualaikum warahmatullahi wabarakatuh and good day. So in this video, we'll continue chapter 4, the last subtopic, which is order statistic. So from previous video, in chapter 4, you have learned function of random variables. Okay, there are three methods can be used to solve the function of random variable. The first one is the method of distribution function, the method of transformation, and then here you have univariate and multivariate. Okay, multivariate you can use Jacobian, and then the last one is the method of moment generating function. So in this video you will learn order statistic. So basically many function of random variable of interest in practice depend on relative magnitude, okay, magnitudes of the observed variable. That's mean from x1 to x3, what is the magnitude, okay? So for example, we may interested in the fastest time in an automobile race or the heaviest mouse among those fed on a certain diet. Okay, so we want to see which one is the fastest one. So we need to order the observed, then look their magnitude. Then you can see which one is the fastest one. So the resulting order variables are called order statistic. So consider let y1, y2, y3 until yn denote independent continuous random variables. Okay, so you can see here we have y1 until yn. This one we consider independent continuous random variables. Okay, so you learned before what is continuous random variable with distribution function fy, okay, capital F, and density function small f, fy, okay, and then denote the order random variables of yi. So this one from y1 until yn, the ordered random variables become y subscript bracket 1, 2, 3, and so on. So you can see here we differentiate the random variable and the ordered random variable by bracket. Okay, so the y1 should be less than y2, y2 should be less than y3. Okay, this is and then so on until yn. Okay, because the random variables are continuous, the equality signs can be ignored. Okay, actually the equality signs they can be ignored because it's a continuous. So using this notation, so y1 will consider minimum of y1, y2 until yn. Okay, because this one the smallest one. Okay, because if we order here, y1 should be the minimum one, the smallest one. However, the yn should be the maximum number of y1, y2 until yn. Okay, so the probability density function for y1 ordered, okay, and yn ordered can be found using the method of distribution function. Okay, this one you have learned in this chapter, the first method. Okay, so first what should you do? So as usual, okay, as the method of distribution function, first you derive the density function of yn, and then because yn is the maximum of y1, y2 until yn, so the events will be yn ordered less than equal with y will occur if and only if the events yi less equal with y occur for every I from 1 until n. So you can see here, this is the mathematical notation. Okay, you need to find this one first, whereas the ordered yn should be less than y. So this one equal with y1 less than y, y2 less than y until yn less than y. Okay, so this is continuous. Okay, so because the yi are independent, okay, and probability yi less than y equal to distribution function of y for I from 1 until n. So it follows that the distribution function of yn is given by this one. Okay, so this is another that you this one that we want to find, and then here the distribution function, because it's independent, you can multiply 1, 2 until n. So this one actually, if you multiply, you get fy power n. This is some theorem that you have learned before as well. Okay, and then you let g and y denote density function, okay, of yn. So how you get? On taking derivative of both sides, you can see that you will get n, okay, this one you differentiate, you get n, this power kan, so you differentiate n, fy, n minus 1, fy, you differentiate inside. So you get the density function of this yn, alright. So the density function of y1, that one is for yn, okay. Now the density function for y1 ordered can be found in a similar manner. So similar lah, you use method of distribution. So what should you do first? Find the distribution function of y1 ordered. So you will have this one. So this one equal with y, probability y1 less than y. So if you look here, this is less than y. So you can use this notation, okay, in order for you to get everything, okay, because this is y1, okay, but actually you have 1, 2, 3 until n. So you can have 1 minus y1 greater than y, okay, because y1 is the minimum. This is the explanation lah. Because y1 is the minimum of all this, so it follows that the even y1 should be greater than y. That's why we use 1 minus here. Occurs if and only if the events yi greater than yi from 1 until n, okay. So because yi are independent and we have probability yi greater than y equal with 1 minus distribution function of fy, so we will have this one. Okay, this is the mathematical notation. So finally, when you times, okay, because it's independent, you times, you get 1 minus fy power n. So this one actually you can simplify. Okay, so thus if g1 y, okay, this is ordered density function. All right, in order to get the density function of y1, so differentiate both sides, so you will get this one. So if you look, actually you get the same thing. All right. Okay, so now we try look, okay, the theory that we discussed previous slide, okay. So now we consider our n equal to 2, okay. Oh, this one, n equal to 2. Find the joint density function of y1 and y2, okay. So the event should be y1 ordered less than y1, y2 ordered less than y2. Means either y1 less than y1, y2 less than y2, okay, this one. Or you can have like this as well. Alright. So notice that y1 ordered ni bracket could be either y1 or y2. This one don't be confused. Okay. Y1 ordered ni means the minimum value. Okay. But here y1, y2 just to show you we have two random variables y1, y2. Okay. But y1 ordered the minimum value either y1 or y2. So it can be y1 or y2 here, okay, which is smaller. So this one take note, all right. So therefore, for y1 less than y2, so probability y1, okay, which is minimum value less than y1, y2 less than y2 is equal to the probability of the union of the two events, which is y1 less than y1 and then y2 less than y2, and this one as well you can have it, okay, because y1 ordered ni we didn't know is it y1 or y2, okay, so therefore it's have union of the two events, okay, it can be like this, okay. So that's it. That is the y1, okay, the minimum value less than y1, y2 ordered less than y2. So this one is a union. That's mean y1 less than y1 here, or union. That's mean it can be y2 less than y1, y1 less than y2. Okay, so this one actually because of here. Okay, so you must clear that. You must differentiate. Okay, y1 ordered with y1. Okay, it's different thing. y1, y2 is a value, but y1 ordered between these two, which one is the minimum value? Okay. And then using the additive law of probability, and we call that y1 less than y2. This is the value, okay. We see that y1 ordered less than y1, y2 ordered less than y2, okay. But using the editing law of probability, so you can have this one, okay, because union, then you can have plus. Remember this one you learn in counting and probability. And then you must minus with y1 less than y1, y2 less than y1. Okay, So you can see like actually you have these two union, isn't it? Union. But in order for you to get here and here, you need to minus this one. Okay. Alright. So because y1, y2 are independent, okay, so the probability yi less than w, so this one equal with distribution function of w. So w ni we just consider something new, new variables, okay, for I from 1 and 2. Okay, so it follows that y1 less than y2. Okay, so you have this one, and then because it's independent, you can multiply this one. Okay, fy1 distribution function of y1 times distribution function of y2 plus distribution function of y2 times distribution function of y1 minus distribution function of y1 times distribution function of y1. So this one, when you simplify, you get this one. Okay, actually this one from here and here. All right, and then if y1 greater than y2, so recall that your y1 is less than y1 ordered is less than equal with y2. So you have this one, okay? So you will have this one as well, okay? It's straightforward. Then this one, because independent, you have fy1 distribution function y2 distribution function of y2. So when you multiply, you get distribution function y2 square. Okay, and then you summarize the joint distribution function of y1 ordered and y2 ordered will be like this. So the first one, if y1 less than y2, this is the distribution function. But if y1 greater than y2, you will have this distribution function. And then in order for you to get the density function of the joint distribution for y1 ordered and y2 ordered, you will differentiate the first one, which this one with respect to y2, and then with respect to y1. So you get 2 fy1 fy2. Okay, and then this one you differentiate, you get 0. All right, so here the same method can be used to find the joint density function of y1 y2 until yn, which turns out to be this one. Okay, so finally you will get this distribution function, or sorry, this density function for y1 ordered until yn ordered. Okay, so here you must clear the ordered value and the value itself is different. Okay, and then when we have ordered value, we look at the relative magnitude. Okay, in the next video we will see the example, and then you can see more clearer. Okay, but here you can see here, before I finish the video, this one actually from basic theory from counting and probability. Okay, and important here is ordered statistic. All right, okay, so we'll continue with next video with example. Thank you, class.